We're in lab 12. We're going to do two short exercises on insurance, and then I've got kind of an interesting problem I made up on a practical problem on inventory management of some kind, okay? And we'll play with it after a while. But insurance is one that's important right now. So we've got some historical data here, historical yields and prices. We have a projected price, and we have some insurance policies. We've got 5 scenarios, 5 possible insurance policies that we could work with. And we want to program this and find out which is the best insurance policy. Now, this first worksheet is on yield insurance, and the second worksheet's on revenue insurance because there are 2 different types, okay? So we'll just start out here. We know that those are the scenario variables, and that's the level of the insurance you buy, 65, 70, 75, 80, or none, okay? And the insured price is $4 for wheat, and the premium's 5.5 up to 7.5, and then 0 if you don't buy insurance. And the APH is just a set number at 26.1. And so I'm just going to do equal scenario, left parenthesis, and highlight those 5 potential values like that. Okay? And then I'm going to drag that formula down for all 4 of those variables. Now notice it picked up the 0 for this last value here for this scenario 5. Even though there's no number there, it's going to be an implicit 0, okay? So don't worry about it. You can type a 0 in there or leave it out. Okay, we need a stochastic price, and because we're trying to do a lot of stuff in one evening here, one lab session, we're just going to do a one-step multivariate empirical, okay? So I'm going to use a one-step NV-EMP for speed, okay? And first speed is good enough. Okay, equal NV-EMP left parenthesis. Okay, so at that point we're going to use a function editor, f of x. We've done that before. So we go to f of x, and it says I need to know the values in the matrix, and so that means it needs the historical data up here. So we're going to highlight the data like that. Then we need the forecasts. And the forecasts happen to be in 2 different places, but we're going to use these right here in row 28. So that's our forecasted values. Now with a multivariate empirical, we have a choice. When we scroll this bar down, and our calculation type, we're going to use 2, which is, and it says it's a % deviations from trend. Okay. We could use from mean, it wouldn't really matter. If we don't want to hit enter, we want to hit Control-Shift-Enter. That'll give us 2 values. Okay. So I'm going to highlight that so we can check that. Okay. So it's the historical data, 4 commas, the forecasted value, comma, 2. And I'm not going to do multiple years, so there's no use. You don't have to lock the rows and columns on your data, okay? Because it's just going to be 1 year. Good? And so that's got us some random numbers. And I'm going to go to expected values so we can go through and check our numbers as we go through this little simulation model here. Now, what we're trying to do, remember, is this. We've got a probability distribution looks like that, and the APH is this value here, and we're going to be insuring a fraction of the APH. like that. And so we've got to have actual yields, and we're going to draw actual yields, and they're going to be all over the place like this. We could even have some high ones. Okay, and we're going to pay insurance from, say, this level up to that level, if that's our actual yield. Okay, so I need an actual yield, and that's the first thing it asks for here is equal, and it's going to be that 29.556. Now, in a statistical sense, what you wouldn't say is actual yield, but you would say it's the realized yield. It's the yield that we actually realized that year. Okay? So that's the more appropriate term for it. The insured yield, okay, that's going to equal that loss fraction. Okay, we insured at 65% times the APH. Okay, that was that first insurance policy. So that's what we've insured at. And the lost yield is an if statement. Okay, or it could be a max statement. But I like an if statement because it's more direct. If my actual yield is less than the insured yield, then the amount I lost is the insured yield minus that actual or realized. Otherwise, it's zero. So the if statement's very straightforward. If my realized yield is less than what I insured, then I have a loss. And you can calculate that. And the insured price, okay, that's equal to that value up there in B23, which was our insured price. That's the one that's on the insurance policy that says, this is the price. Now, indemnity per acre is going to equal, okay, we're going to write that out. It's equal to the, you can't have an equal. Excel thinks it's a formula if you type equal. It's equal to the lost yield times the insured price. Okay. So let's put that in there. So I've got an insured price here times my lost yield. And of course that's zero for the moment. We have a premium, okay? And the premium is always equal to the acres planted times the premium or dollar per acre premium. So we'll have 1,000 acres times that premium up there at $5.50. Okay, I'll raise this up a little bit so everyone can see better. Okay. Now, I'm going to go off the expected value for, I'm going to hit save. I'm going to go off the expected value so we can see what happens if we have, I got a loss right off. Okay. I produced 12.6 bushels. I insured at 16.97, so I had a loss of $4.32 times $4 is about 17.25. Right? Okay, so hit F9. Now, there's another way to check this really easy. Okay? Okay, since we're insuring at 16.97, if you typed in 15.97 right there, it would come back at 0.99. There's some round off in there, decimals, times $4, it would be $4. So you can check yourself. Now, you don't want to read it like that, so you hit Command Z, and it puts back in your stochastic value there. Okay? So you can type it in, just for a minute to check it, because what you got in front of you is the biggest calculator in the world. Okay? It's not like these little 3 or 4, 10 key calculators like this thing here. By the way, did anyone lose this? It's here. Okay, if you did. There's always an assortment. If you're ever short of a calculator, you can go into these and there's always 1 or 2 in there. Okay, now, back to this. We have to disinfect it, of course. Okay, you have $5,000. Okay, now, this is the indemnity per acre. Okay? Now let's start trying to find total revenue so we can look at net return. Okay? So our market price is equal to this number up here, stochastic price for right now. Okay, and I'm going to go back to expected value so we can compare what we're doing. We've got our actual yield. That's that same numbers we had before. Okay. So our market receipts are going to equal the price times the yield times the acres. Okay. We have 1,000 acres. So price times yield times acres. This is the thing that's constant across all languages. Okay, indemnity, there's going to be this indemnity per acre times the 1,000 acres that were insured. Okay, and the way the insurance works, you have to insure all of a field or all of the wheat on all of your fields. You can insure one field at a time, or you can insure all of them. Okay. Question? Anyone? Okay, good. Now, total revenue is equal to this market receipts plus that indemnity. And that's what you're going to have on your income statement. A premium, we've still got 1,000 acres. Oh, we've already multiplied by acres up there, so we can just say equal this. And if that's the case, I'm going to change the text on this one. Okay. So now it's correct. Our cost of production is going to equal that 1,000 acres times that production cost per acre. Okay. So we can sum total costs, and it's actually just the premium plus the cost of production. And then net returns, just like in your income statements, receipts minus total costs. Okay. Very, very simple. Okay, that's going to be my key output variable that I'm going to send over for simulation. So I'm going to paint it yellow and make it bold. Okay. So hit save. Go back to simulation. Now, before we hit simulate and test this, has everyone got those numbers? Okay. Any questions, any place? I don't want to run off. We've got plenty of time. Okay. Now, so I'm going to simulate this, and Brad, how many scenarios are we going to run? Wait, Brad's not here. What happened? Yeah, that's going to pick on him tonight. Okay. Who else can I pick? No. Okay. So we're going to run 5 scenarios. Okay. Simulate, label on my left, click that, and I'm going to tell it 5 scenarios. Well, let's send this to send data yield insurance, INS. And it's running. And it's fast. Okay? So I got answers that look like this. Do we get numbers that look like that, folks? Okay. So, two things I want to do with that. First, I want a CDF chart of it to see how these interact. Okay. Okay, they cross significantly. So that means I need to run surf on them to see a ranking. Okay. So we come in here, go stochastic efficiency, highlight those values. Labels, add, upper rack, we'll put in 3 zeros and a 1. And we get something that looks like that. Now, I had several people ask me, so I'm going to talk about this right now. Okay. If you have these charts overlapping each other, these lines, where you really can't tell one portfolio, this is in problem 1, portfolios, where you can't tell one portfolio from another for ranking because the lines are so close together, which you've done a really good job of. Okay. And if you're trying to rank this for a moderate the risk-averse person, okay? Remember that if we talk about this area here is for an extremely risk-averse person. This one's for a neutral, risk-neutral person. And then halfway between here and there, so right about here, is for moderate. And halfway again, which is a fourth of the way back, is for a normal person. Okay? Well, these numbers that are graphed here come from this table. So these numbers are over here. There are 25 of these, so half the way is right here. So these are the numbers associated with these chart values right here. Okay? So if I'm going to rank for a moderately risk-averse person, I should be able to look at this and say, this one is number 1, this one's number 2, that one's 3, that one's 4, and that's 5, based off these numbers in here. Right? Makes it a lot easier. So what you should do for this homework is print this. Okay? And if you're going to do this for a normally risk-averse person, you go back about a fourth of the way. So there are 25 of these, and 25 divided by 4, I think, is still in this neighborhood of 6. We would use this ranking right here. And again, that's 1, 2, 3, 4, 5. Okay? So it's a little bit different there. Okay? So that's how you would rank those. Question? Yes?
Sir, the lines do not overlap or cross. I have the same CDF, a very similar CDF.
Okay, yours do not overlap any place, even back here at the very beginning, at the early stage?
No, the whole time my
okay.
yellow is above it.
What rack level are you using?
0.0001.
Okay, so the same one I've got there. Okay. If you look at your sim data years, do you have the same means and minimums? Yeah, if you don't have the same values here, then the surf charts can't be the same. Okay, so there may be something in here that you and I did different. Okay. Does anyone else have a significant difference in this chart?
I did.
You do? Or you always do?
It's because I accidentally grabbed the market receipts and not the total revenue. So maybe
Oh.
that.
Yeah, if you're calculating the net returns down there using market receipts instead of total revenue, because, okay, yeah, because then you're ignoring that indemnity part of the time. You're not going to get a huge one, but you should get one once in a while. Okay? That'll make a slight difference in it. Okay. Let's move on. Revenue insurance, okay? And that's in the other worksheet. And we're going to calculate this, okay? Now, in the interest of doing this, we're going to again start with equal scenario, left parenthesis, and we'll highlight those 5 values. And then we can drag that equal scenario formula down. Again, I'm going to stay in expected value. We could generate stochastic price and yield again, but since it's the same distribution, I'm just going to say it's equal to the values we had over here in the yield insurance. So it's just equal to that stochastic price and yield from the page before, the worksheet before. Now this time, we're worried about yield and price combinations. Okay? So we're going to calculate the revenue loss. Okay? So to do that, I need the insured price. That's at $4. It's B23. So equal B23. The APH equals B25. Oh, let's put some B formula in there. And I'll just run that all the way down. So it'll automatically fill as we go. Planted acres, that's equal to that 1,000. So the insured revenue is the price that you're insured at times your 10-year average yield times the number of acres that you insured. Okay, so you might think of that as a long-term average revenue given today's market price. Okay, or our forecasted market price. Okay, so it's 104,400. Put a comma on it. We don't need any additional accuracy. Okay, now the actual yield. Okay, we're going to take the yield itself, that's stochastic yield that we realized. It's in C29 times, or I'm going to multiply it times the actual stochastic price. Okay, I'm going to multiply those together, and you know, I've got to have acres in there also. It doesn't call for it right there, but I'm going to put acres in. Otherwise, you can get an indemnity every year if you didn't put acres in. I'm going to put in yield and put in market price. Okay. Now, my realized revenue is $125,000 roughly. I insured at $104,000. Okay. Let's draw a picture of what we're looking at here. Okay. So, I don't really know the shape of this distribution, but that'll do. So I'm insuring at $104,400, and right there I drew a revenue that's $124K. Okay? Now, oh, that's what I left out, this number here. This loss fraction, because we need to be at some fraction down here that we're going to insured revenue. Okay? So let's go put that in. That loss fraction is equal to what we insured at 65%, the revenue loss fraction. Okay? Now, guess what? We're going to modify this formula here by multiplying by that 0.65. Okay. So you can get in a hurry and forget something, and then it kind of dawns on you if you draw a picture of what you're supposed to be looking at. Okay. So my revenue is going to have to fall below, the actual revenue is going to have to fall below 67,860 before I get an indemnity. Everyone see that? Okay, good. Now, let's figure out what our, I'm just going to add a row in here, lost revenue. Okay. We'll do that with an if statement. If this revenue here, my actual or realized revenue, is less than what I insured at, then I'm going to take the insured revenue minus the realized market receipts, otherwise zero. So, if this blue box is less than the red box, and take the red box minus the blue, this will only be positive if you do it that way, or zero. And so the indemnity is going to equal this lost revenue. And because we've already taken into consideration the insurance fraction. The premium is equal to acres. So we've got 1,000 acres here times that premium up above. And it's in B24. So my net returns, I've got costs someplace. I'm going to have total revenue. Okay, let's make a note over here what it's supposed to be. It should be total receipts plus the indemnity minus the premium minus the cost of production. And I really don't like to put all that stuff into a formula, so I'm going to add something here. Just put in cost of production. Okay. And that's equal to that 1,000 acres times $85 an acre. have all the components we need for net returns. So it's equal to the realized receipts plus my indemnity minus the premium minus my cost of production. Okay. This is just pure, simple economics. Fund management. Okay. And we've actually got net returns, and I don't know why we've got all this stuff here, so let's just delete it, get rid of it. Okay. Now, it's a good time to hit save. Now, if we come in here, and these are our two stochastic variables, right? And what I want to do is find out if my formulas are really working before I go off and simulate and waste hours and go see the professor and my neighbors and beg them, okay? So let's find out if this is going to work. So let's just type in a 0 for the price, okay? So we get 0 revenue. So if you do that, the indemnity should equal to what you insured. Correct? Yeah. Okay. Then hit Command Z. Okay, now let's put in, say, $2. Well, we're going to indemnity. We're at 59,000 realized market receipts and 67,000 there. So the difference is about $8,000. Okay. Let's put in Command Z again. So what happens if our years go to 20? No indemnity. Okay. What if they go to 10? Oh, I get an indemnity because revenue is now 25 and the indemnity is 25. Okay. Well, the realized receipts are 42 and indemnity is 25. Okay, Command Z. So you're actually ready to simulate that. And if we,
Still at 20.
oh, thank you. I was wondering why it wasn't doing anything for me there. I had a permanent indemnity. Insurance folks don't really like that. Okay, let's save. And we'll go simulate this. And I'm going to clear out the output. I'm going to do an add. And I'm going to simulate this and send it to revenue. Okay. And it's still 5 scenarios. Daniel, did your problem work out when you put 9 scenarios in? It's amazing. Okay. If it only runs one scenario, you've got to check that little box to see if you only have 1 up there. Okay, now what this does is you may still get some negatives in there. We need to do a CDF chart of that. And hopefully this actually worked. Whoa. And it gives us this really neat chart that we can interpret now. Okay? What it's telling me is that if we take that black line and come over here, it's telling me that about 14% of the time, this insurance, number 1, is going to pay. Okay? And if you look at the green one, it's right at the 20%. So the green, which is number 4, pays 20% of the time. Okay? Now the yellow one is no insurance. and it never pays, okay, because you didn't pay a premium for it, you didn't buy it. And what it's doing is this horizontal shift from any line to the yellow one is the cost savings of the premium. And so if you don't have low yield or low price and you didn't buy insurance, you're better off. That's what it's saying. You're better off by that much money, which is the premium that you would have paid. Okay. But if you have a loss, then you're better off by the integral of this area under that yellow line there, up to the level of insurance. Say you're going to buy the red one. So this is how much, this is the probability here of losing money because you didn't buy the red insurance policy number 2. Okay. The other thing we can say about this is if we come all the way to the bottom and take advantage of these formulas that are embedded in here, okay, it will tell you the probability that these policies pay off. Okay. I want to insert a line there so I can actually talk about this. This is equal to 1 minus that probability there. So it says 74% of the time you're not going to get a premium or an indemnity. Okay. 20% of the time, 26% of the time you're going to be below 0. Okay. 25, 25, 25, 26, 20. Okay. So you've got, and it doesn't interpret the way I wanted it. The other thing you can do with this, let's go back up. I'm going to insert about that many new columns in here. Okay. How many is not all that relevant. Let's go back here, and oftentimes people want to know how much indemnity they're going to get relative to the premium, which is called a loss ratio. And it's going to equal indemnity divided by the premium. And I'm going to add that to my output variable, going to simulate. Okay. So again, that is the indemnity divided by the premium. I'm going to add that. I'm going to simulate it for the 5 scenarios. Okay. And we've got an average loss ratio. Oh well, I think the premium in the on the no insurance, so it's going to divide by 0. Okay. So what this is saying is that you have a loss ratio of 44% under the first policy and as high as 66% under the last policy. You're buying higher and higher levels of insurance. Okay. Now, if this loss ratio gets really high, the insurance people are going to increase the premiums on you. Okay. They want the loss ratio to be lower, less than 1. Okay. So that is another variable that you can look at when you're evaluating insurance. Questions on this? So this is how we do revenue insurance. Very simple. It's actually it's just about as simple as doing yield insurance. Now, in the real world, there's one other feature that we would put in here. And that is, instead of just taking the stochastic market price, we would have to have a stochastic futures price at harvest. And the formula for doing that is a little bit more complicated than I want to go into. But if you're going to do that for your research, come and see me and I'll show you what that is. It's an exponential, funky looking formula that's a function of the marketing year average price here. Okay? So that's all you would do, and you would use that for calculating your indemnity. Okay. Instead of this market price for the indemnity, you're going to use the futures price. So this is called, if you exclude that, you pay a different premium, and it's called market price exclusion. Harvest price exclusion, I'm sorry. Okay. Question on insurance? Okay. So this yield insurance section, that's where you should program your homework problem 3. Okay? You've already done that by now, and so this is a perfunctory. Okay. Well, let me give you something that you haven't thought about. Okay. I always like to come with something easy to build up your confidence, and I'm going to tear it down in a minute. No, let's do something serious here. I want you to bring up Lab 12 feedlot inventory. Okay. This is kind of a perverted inventory management problem. Okay. And I dreamed this up in the last day or two and programmed it today, and I left some equations out and I included some other equations. Okay, let's start with the context of this problem. We've got a feedlot. We're going to put 1,500. We're going to buy 1,500 steers. They weigh somewhere in the neighborhood of 650 to 700 pounds, something like that. Okay, stochastic rate, because we've got an order buyer, and she sometimes brings me what I want, and sometimes brings me heavier than I wanted. Okay, so we've got that. We have a stochastic price, and I'm going to have to pay for the steers. I've got a stochastic gain on them. Okay, they don't all gain the same amount. Okay, some of them die. Bummer. We're in real life here. Okay, so we have. Oh, we don't need to teach these people. They didn't pay. They didn't pay tuition. Okay, so if we look at this, we've got 1,500 head. That's the only number we know for sure. Okay, purchase weight 650 to 700. Sell weight 1050 to 1200. And we're overfed them a little bit. Okay, death loss 5 to 15%. Depends on whether you're feeding in the spring, fall, or winter. Okay. Corn bushels per pound of gain 0.07, 0.09. That's not a bad range. Any corn that we have left over at the end of the feeding period, we have to store. Okay, we're just going to run this pen one time during the year. Okay, and if we have to buy corn, it's 25 cents over the marketing year average price, and we're going to contract with a farmer to grow corn for us, put in our feedlot. Okay, because we can buy it from this farmer cheaper. Okay, literally we own the farm. Okay, let's think about this. There's a feedlot named Cactus Feeders. Okay, they feed a lot of cattle. They have a lot of farmland. Okay, they raise their own corn. Okay, so the question is, how much corn should we raise? 200 acres, 225, 250, 300, 400, however much. Okay, if you raise too much, you could sell it on the market, but a lot of these feedlots have the old man philosophy that, like grandfather's philosophy. If you ever sell a bale of hay, you're going to have to buy 2 bales in the spring to make up for that one you sell. Okay? Learn that from Montana ranchers. Okay, now, corn harvest, production cost and harvesting costs, we've already played with that game before. And we're going to start with 4,000 bushels of corn. Okay? And so we've got an inventory problem. I'm going to simulate this for 4 years to see how the inventory formulas hold up. Okay? Just trying to put something practical here. No, it's not really practical, but it uses some of our formulas. Okay, so we've got something really simple. We've got some uniform distributions here for some of our random numbers. So let's just do that. Equal uniform, rough parentheses, and they're in the right order. So I can, if I do this right, I can type that formula one time, drag it across, and drag it down, and I'm done. Okay? So, I need to lock what? I'm going to lock the column. Okay? Comma. And then I want to make sure that I get the corresponding maximum and lock that column. Parenthesis. And by the way, all of the B formulas that are necessary for these formulas all the way down are copied and pasted as values in here in case we get lost. Okay? That's why they're showing up there. Okay. And if I drag that across, I should get that. I'm going to go to expected value. Okay. Now, I should be able to drag that down. And, well, okay, I know what's wrong. We need more decimal points. Okay, because death loss is not 0. Okay. So, did everyone get numbers like this? Okay. So, that's what we start with. We bought 1,500 head. Some of them died. So we need to calculate our number that we would sell. So that's going to equal our 1,500 minus, well, it's 1,500 times references 1 minus the death loss. And I put integer on that because it's hard to sell a half a cow. I tried one time, they didn't like her. She had too big a pink eye, and so they kicked her back. Okay, so half cow doesn't count, so we're going to integerize those cows. And so I'm going to sell 1,350 right now in expected value. And I'm going to demand that much corn for those cows, okay? And let's just look at that formula I programmed in there. We started at 675 pounds. We sold it at 1,125. So that's how much gain we had. And it took 0.08 bushels per pound of gain. Okay, so you multiply those out and it works. Okay? And that's how much corn we really need to feed those 1,500 head. Now the acres of corn we've got is equal to, and that's that scenario number right there, B9. I'm going to hit F4 because I'm going to hold that constant. It's B9. So how much corn do we produce? Well, oh, by the way, where did this yield come from? Let's go down here. And I had some historical data on corn price, stocker steer price. This is the ones that the 650 pound ones we buy. And the fat cattle price, that's what we're going to be selling. And so I just, for simplicity, and notice it says, to simplify the problem, I used the same mean for all 4 years. Okay, I didn't want to put a whole lot of work into this. So I simulated that as a one-step multivariate empirical. Okay? Again, to simplify it and to make this doable. Okay. So that's what we've got. So I just brought those numbers back up here. And I simulated them one direction, then I transposed the matrix so I'd have years going across for my variables. Okay, we've all done that before in homework, right? So now let's keep filling in this matrix. So the corn that I produced is equal to the yield per acre times the number of acres. Okay. The corn that's available for feeding, okay? So what this is where the inventory starts getting in here. It's equal to my beginning stocks of corn, which is at B12, plus what I produced. Okay? Now, I'm not going to drag that across because that's got something going on here. If I have surplus corn, that would mean that what I had available was more than what was demanded. So that's an if statement. If my inventory, and you could, so that corn available, you could also call that my inventory. And instead of saying corn purchased, this could be how much you ordered in. Put it in those terms. So my surplus corn is equal to if this corn available is greater than the corn that was demanded, then I'm going to take the demanded, this available minus what was demanded, otherwise it's 0. Okay, so it's just common sense here. If you need less than you have, then that's going to be a surplus. Okay? Otherwise, it's 0. Now, that formula I can drag across. And deficit corn, this is corn I'm going to have to buy because I just didn't produce enough. That's equal to if this corn available is less than what they demanded, then I'm going to use what's demanded minus what's available, otherwise it's 0. I think I did that right. Okay, yeah, came out 8,000. Now let's go back up to this row and I'm going to highlight it because that's one of those that you have to do in the second step. So in the next year, how much would I have available? Any question? Yes?
Yes, sir. For the corn deficit, I know that when we do our cash flow deficits in our models, we put a negative in front.
No.
Okay.
We're not going to do that. Okay. Because this is what we have to go buy or steal.
Yeah.
Okay? Okay. So, I did tell you about the student who did the feedlot model, made a horrible amount of profit because she wasn't feeding her cattle. Okay? Yeah, she was going to go back home and tell her dad, we should be putting a feedlot here on the ranch, and until I looked at it and I said, you got to feed them. And when you buy feed for them, it takes your profits way down. Okay. Now, corn available. How much real corn do we have available this year? We have what was produced, what was any surplus the year before. Okay, let's add those two together. Okay? So it's equal to what was produced plus anything that we had surplus the year before. Okay? And that one we can drag across. And so it looks like that. So I'm managing my inventory a little bit. I'm just keeping track of it right now. Now, before we go any further, I'm going to come back up here and I'm going to try to split my screen here with that view split. Okay, everyone do that? And I'm just going to change that number right there. Just for a few minutes. I'm going to put in 400 acres. Okay, if I have 400 acres of corn, I'd be producing 76,000 bushels, and I've got surplus corn. Okay? So I've got surplus corn of 28,000, so now I can see that that surplus equation is working. And it bills. Okay? So it's literally, I've ordered too much corn. Okay? And in a feedlot situation, you're contracting for corn literally a year in advance. Because you have to know what the cost of gain is going to be a year in advance, or at least 6 months in advance. Okay? So let's change that 400 back to 200. Okay. So now we've kind of verified that equation. I'm going to double click on this. Yes?
For your deficit corn, you use, you use the corn demanded minus your corn available. But the formula you have copy and pasted there is your corn demanded minus your corn produced.
Okay, let's see. Corn deficit, well, you can write that formula either way.
But at the, so.
Let's see, is it right now? Because it says, if I demanded 48,600 and I only had 40,000, I'm short by 8,000.
But the formula that you have right there.
Right here? Yeah.
Is using your corn produced
Mm-hmm.
instead of available.
Yeah, it is. Get rid of it. Equal B formula.
Thank you.
There we go. That's better now. Okay. Thanks for catching that. I didn't see it. Okay. Corn raised. Okay, we've got the corn, the cost of corn, that's $1,000 times it's 200 acres times $300 an acre. And harvesting cost is going to be our production, right here, times the cost per bushel to harvest it. So I left some equations in here. Now we have to store corn. And the thing is if you have an inventory, you've got to keep it dry or it goes out of condition. Okay? And I know an MRO, it doesn't get wet up there often enough, but you still have to store it. And you're going to have to pay someone to insure it. And I put in a very low storage cost here. Okay? Just assuming that this operation owned their own elevator they could store it in. So really all we've got is electric cost to keep circulating air through it. So it's equal to, and it's going to be the storage cost up here in B11, and we'll hit F4 on that, times any surplus I have.
Why did you select the lowest?
What?
You selected the lowest cost?
Did I? Oh, I did, didn't I? Yeah, it's not that 20 cents. It's the 25 cents. No, it's a storage cost right there in B20. And it's going to be stochastic because why? Electricity cost is stochastic. And and I edited the wrong formula there. Storage cost, surplus. And I don't want a dollar lock on that. Okay, cost to purchase corn. So if you have a deficit, you have to go pay for that corn. Oh, by the way, that price of corn that you're going to have to pay is that local wage, 25 cents a bushel up above, and the stochastic price down below. So our cost to buy corn is equal to this deficit corn. That's why it's not a negative, okay, times the price of that corn, $3.41. Okay. Now we get to buy some steers. So the cost of the steers is going to be the price of the steer, so it's equal to that price, times the weight of the steers, which was stochastic, and the number of them. Okay. So it's B16 times, and then we've got that number 1500 up here in B2. We'll hit F4 on that. So B37, B16, and B2. Okay. Now you get to sell some of them. So that's going to equal the price times the number of head that you get to sell, which is in B23, times their sale rate in B17. Oh, I gotta. So our return over corn, and if I could have made a more complicated formula, I would have, I guess, is equal to the receipts for steers minus the cost of buying steers in B38 minus the cost to purchase any surplus corn that we needed, deficit corn, in B36 minus the value in B33, which is the cost to harvest corn, minus the cost to grow it in B32, minus the storage cost of corn in B34. Now, if I'd been thinking, I would just added up all the expenses in one place, but I didn't. I was in a hurry to get this thing ready for class. Okay? So we have, and this just makes you want to go into the feedlot business, doesn't it? Because the honest truth is, you've got $218,000 to buy forage and soybean meal, vet medicine, because they all get sick, and hire labor, and pay yard costs, beverage costs out there. Okay? So just run that out there and put it in feedlot. It's a good idea. Okay, I wanted to, and we've got 4 years worth of this, and I needed to get it down to one variable, so I just took the present value of this net returns above the cost of corn. Okay, so save that. Let's turn this on to stochastic and see if this is what we want to do with the rest of our lives. There are a couple of negatives in there, and remember, we still got to pay labor, management, and all those other expenses. Okay, so how many scenarios do we have? We have 4 scenarios. We're going to simulate this present value of net returns over corn. Left, output, 4 scenarios. And we're going to put it in SIMData, SCEM, because it's already programmed for us. By this time, I think you all know how to draw CDFs, and so. Okay, there we go. We get nice crossing CDFs. Okay. We get some negatives in there. We get some fairly big ones. And if we look at surf, you get a ranking. And sure enough, for that extremely risk-averse person, you get a switch. These lines cross. Okay? So somewhere between the number of acres for 2 and for 3, you get a cross. So if we go back and look at the scenarios, scenario 2 is 225 and scenario 3 is 250 acres that we'd contract for corn. Okay. And if you wanted to see the numbers on that, you could look at them over here. The other way of looking at that is in terms of the risk premiums. How much would you be willing to pay to move from 200 acres up to the 225 acres or 250 acres? That's about $16,000. Okay? So, what I toyed around with here is what happens if you cut this back. Let's go to 150 acres, and we take that to 200, make that one 300, and 400. So yesterday when I was talking about managing inventory, I was talking about order points. Okay, how much corn do you order? How many acres do you contract for? So we can set up a what-if question right here, simulate that, and see what the advantages or disadvantages are. If you start producing a lot of surplus corn, that's scenario 4 where we had 400 acres, what does it do? It costs you because you have to carry an inventory. Okay? So the cost of carrying that inventory, and the cost of that in there is really cheap. Okay? It's probably more like 15 to 20 cents a bushel for storing grain over a year. Okay? So this is inventory management in agriculture, in input. And if you didn't want to work with a feedlot, you could do a wheat mill, a flour mill. How many acres of wheat do you want to contract with to make flour? You've got a stochastic demand for flour. Okay. The other one is you could just be a feed mill. Okay. Like Co-op down here, they buy ingredients to make feed for livestock. Okay. So you've got corn, soybean meal, alfalfa meal, and some vitamins and minerals that you can inventory. Okay, I did a lab exam problem with a seed company one time and blew the students' minds. Probably never do that again. The nice thing about a seed company, you have to go out and contract for different seed varieties to be produced. Okay. And there's a lot of risk out there. Okay. And the other thing is with a seed company, when you get down here and you have a surplus, this year's seed has a very low demand next year because why? The germination rate goes down on it. Okay, so its value is lower. So one of the things you can do with it is you can rip the bag apart, okay, which costs labor, and you pour it into a bin and you feed it, unless it has been treated. And if it's been treated, you don't do that. A huge lawsuit many years ago was somebody found some seed, some corn out at the local dump, and they took it home and fed it to their hogs, and their kids ate the meat, and they died. Okay, so that's one of those externalities that we talked about yesterday about full cost calculation. So this is a problem I put together. I hope it shows you something about inventory. And the real inventory is in this part here, where you have surplus and deficits, and in how much you order here. You can order too much, you can order too little. And the risk premiums will tell you which one is bad. So if you order too much, it could cost you $120,000 if you're extremely risk averse over a 4-year period. That's $30,000 a year. Is that the kind of insurance you want to pay for? That's a pretty high premium, isn't it? Okay. That's about all I have. There's another lab exercise we could do there on coefficient of variation. And I guess we can do that. It'll take about 5 minutes. CD stationarity. We have a historical series here. We can forecast that series. If we were to simulate this using, we need a standard deviation if we're going to simulate with normal, so equal STD EV, which is standard deviation. Highlight the data. Let me enlarge this so we can all see it. Equal V formula. Okay. So if I want to simulate this as a normal, okay, it's equal to norm, left parentheses, that's my mean, comma, and that's my standard deviation. Okay. We can simulate that. We'll enter and equal V formula. And I'm just going to send that off for simulation. No labels, add, sim data. Now, what we're most interested in this example is what's happening to this coefficient of variation. So we're more than 10 times more risky, relatively more risk in the last year out, 10 years out than we were to start with compared to history. Okay? That's fairly bad. Now, what we can do is we could calculate a J factor. And for the J factor, I need an average from history. So equal average, highlight those numbers. Now this J factor, the formula is equal to the y hat, or forecasted value, divided by that historical mean. That animal right there. And if we're using the J factor, or correcting this for CV stationarity, we're going to have normal with a J. And so that's going to equal norm, left parentheses, the mean for that particular year, comma, the standard deviation, we're going to hit F4 on that, and it's multiplied by its corresponding J factor for that mean. Okay, and we'll put some V formula on that. And we can drag that formula down. Okay. So I'm going to send this off and simulate it and stick it up there next to the old one. So I'm at sim data. It's going to add that. Let's simulate. And we've got variables 11 to 20 now are with a J factor on them. And if you look, your coefficient of variation stays pretty constant over that whole period. It's 99.8 to 100.22. Yes?
What were the three variables used for the norm of the J?
Oh, okay, good. They are the mean, the standard deviation times the J factor. Okay? I use the average. That's what I wanted to use. Oh, I use the average. Oh, that average. Ooh, thanks. Okay. Oh, well. We can fix that. But the CV would still be constant. I'll bet you. Okay, let's see. No wonder it jumped to 100. I was wondering, why did that get so big? Okay, so it's at 48, and it stays at 48 all the way. That's the first mistake today that we got caught on. Okay, now, let's do something weird to this. Okay? Let's decide that we need an expansion factor on it. Okay? So we want an expansion. That's our E function. And you can spell it twice and still get it wrong. Just go with E factor. Okay, I want to have no risk the first year, and then I want to increase the risk by 20% each year. Okay, so we're going to have an expansion of 20% per year. Okay, we've got 0. No risk. Okay, next year I want it to be at 0.2. And then I want this to be at 0.2. Oh, let's go back to 1. The neutral. And then equal that value there times left parentheses 1 plus my 20%. And I can't just do that, can you? Okay, how do you do that? Okay. Well, you can say del text, left parenthesis, click on that, hit F4, parenthesis, divide by 100. Okay. And it worked. Okay, let's me show you that. Equal V formula. Now, it would have been easier if I would have just typed a 0.2 up there, right? Okay, I could have done 0.2. It's the same thing. Golly. Okay, so I can delete text. You also know that you can do equal del num and click on that cell and it would give you back the text on it. Okay. Now that we've got that out of the way, let's do the actual calculation over here. So this is a norm with a J and an E. So it's equal norm. Look, okay. I want that mean there, that's my y hat, comma. I want the actual standard deviation, Mason, okay, F4, okay, multiplied by the J factor, and then multiplied by the expansion factor. If you use the expansion factor, you must use the J factor, because J factor brings it back to normal, to a normalized value. Parenthesis, enter.
Isn't that going to give it a standard deviation of 0?
Yeah, and it doesn't like that at all. Let's make that 0.1. Oh, really? Make it 0.5 so it'll be prettier. Okay. And drag that down. And we'll simulate that. If we add it here. Now we've got a whole bunch of this stuff. And see how that coefficient of variation jumps? Yeah, it gets bigger. Okay, so these are the ones, variables 21 to 30, are the ones with the expansion factor in them. The only way to really see this is to draw a fan graph. Yes, Christian?
On the off chance that when we were doing the norm J and E factor,
Mm-hmm.
I got the first one with the 0.5, but the rest of them just show values.
Oh, you know what? I'll bet you didn't reference the standard deviation. Did you do that?
Yes, sir.
And you still got pound values?
Yes, sir.
Okay, let me see how I would have done that. Okay, if you got a formula that looks like that, the mean, comma, the standard deviation locked, times J times the E.
Yes, sir. Oh, I put a comment.
Oh, if you put a comma in the middle of that, then it's going to pick up one of those and think it's a uniform standard deviate.
Oh.
It really will. That's the way it's programmed. Okay, let's get back over here to send data. I'm going to draw a fan graph of this. And I'm going to highlight every variable here, all 30 of them, for 500 iterations, like that. And it does look kind of pretty. Weird kind of way. Okay, this is the original, where we had no J or E. This is where we had a J factor. This is where we have the expansion and the J factor. Okay? So that's what it's doing to it. So you can change anything you want on those expansion factors. I'd be surprised that last one. Oh, it's because the mean is going to virtually 0. Okay. Let's change this around. let's, instead of using these y hats where they're going down, let's have them go up, okay? Let's make the first one, move the first one at 17, make the next one 19, and then we will let Excel expand that like this. Now we can, oh, that doesn't look real good. It's supposed to expand it. 23, 25, 27, 29, 31, 33, 34. I'll make it 35. Be consistent. Okay, if I simulate that, and now, oh yeah, that's beautiful. So, this coefficient of variation out here increased to 200%. Okay? So, we started out with a little bit of risk, and then as we went into a trade war with China and the rest of the world, things got really risky. Okay? So, that's what you can do in the expansion factor. And we're pretty well out.
Dr. Richardson?
Yes?
In empirical distribution, though, it automatically corrects.
The empirical will automatically correct
Okay.
for the J. We don't have to have a J in it.
Yep.
Okay? I'll show you. If you were to come over to column A and do an f of x on that column of random values for x, labels add percent deviations from mean or trend, it doesn't matter. And we can come down, whoa, that's way down there. With one variable, we don't have to do much to it. Stochastic values. Stochastic value is equal to EMP, left parenthesis, the random x's, comma, the f of x. Okay. And if I would have done a real good job of that, I would have cell locked all of that. Okay. So we've got a blue column and a red column. And we'll just drag it down like that. And let's just assume that these are stochastic values, and then I'll put in a set of means over here. Let's let the means go 10, 15, and then Excel should expand those for us like that. So technically the coefficient of variation should be constant or going down, okay? So let's simulate this, okay? So we'll call this EMP 1 down to whatever we're at, 9. So it's equal to the mean times left parenthesis 1 plus that stochastic deviate. And I can simulate this like that. Save it. If I simulate, I'm going to clear all this out. Tell the label on the left, add it, and I'm going to just tell it to go to sim data EMP. And looking at that, my coefficient of variation is constant, even though I tore up that mean substantially. Now, if we want to put an expansion factor on that, this is the way you do it. So this is going to be an EMP with an expansion. Okay? So let's take that, we'll do 0.5, 1.5, and we'll just let that extrapolate. Gives nice big numbers. So this is going to be EMP E1. And I put it in the wrong place, of course. So the formula I'm going to use is equal to the mean times references 1 plus the stochastic deviate times expansion. Okay? And if you generate that stochastic value first, okay, this one, then it's so much more likely that you'll do it right. So it's equal to that mean, wherever, there, times left parentheses 1 plus the deviate times our expansion factor. Okay? And we can drag that one down. We can add it to, that got big. We can add it here, simulate it, and we're out here, and this coefficient of variation goes 23 up to 208. I was teaching a workshop to some students and walked around to see what they were doing and with their expansion factors. And one really imaginative young woman had put coefficients in there so that she drew out a classic Coke bottle. Okay, and you can do anything you want with these expansion factors. You can make them bigger, smaller. You can make them increment up and then come back down. Okay. Okay, we could have a change of regime here, and we could bring that back down to 2, 1.5, 1, and 0.5. Resimulate and see what that does. Okay, it does that. Okay. So the expansion factor can really extend your capabilities in simulating distributions that you don't know about. Okay? Questions? Okay. We've covered a lot. Thank you for your attention. And let's see if we can get this recorded.